Assalamu alaikum wa rahmatullahi wa barakatuh. I am Reem Suwaidi and my colleagues are Khadija Al-Ali and Amna Al-Khfali. We are glad to present our project about the pyrolysis of biomass using radiofrequency heated reactor. This project won't be accomplished without the help of our supervisor, Dr. Abrar. We are going to cover a brief introduction, technical background, methodology, and we will end up with our expected results and conclusion. Fossil fuels are being widely used in several applications, although it's the main contributor factor for serious global problems that can lead to serious diseases and deaths. Because they emit harmful gases to the environment that leads to global warming, ozone layer depletion, and also acid rains. The world needs to shift quickly because humans are paying the price. It is important to mention also that these sources are vanishing. So, as renewable energy engineers, it is our mission to replace these sources with sustainable, environmentally friendly energy sources, such as solar, wind, geothermal, and biomass energy. If we could utilize these sources very well, we are capable to make a great progress toward the green energy future for the next generations. Each type of renewable energies depend on a specific source. For example, solar energy needs the sun's irradiance, while biomass is the only type of energy that can be effective all around the world because it simply converts the landfill waste into useful energy. There are three biomass conversions could be done to meet a specific purpose for several applications. For example, biological conversion uses microorganisms, while chemical conversions rely on simple chemicals and catalysts to develop useful products as biodiesel. And the third one is thermochemical conversion that uses high energy density and low moisture content feedstocks to produce three main outputs: syngas, bio-oil, and biochar. However, these three outputs could be obtained by three different techniques called pyrolysis, gasification, and combustion. In our project, we chose to work on pyrolysis technique that occur on the absence of oxygen. Now, my colleague Amna will proceed.
The amount of pyrolysis output mainly depends on temperature, residence time, particle size, and the biomass used. Several pyrolysis approaches are used to extract a specific output. The most used approaches are slow, fast, and flash pyrolysis. Slow pyrolysis occurs at low temperatures with slow heating. Fast pyrolysis is operated at moderate temperature and high heating rate, while flash pyrolysis is operated at high temperatures with rapid heating. The maximum products is biochar for slow, bio-oil for fast, and syngas in flash pyrolysis. In our project, we chose fast pyrolysis as our approach. The reactor is the core of the pyrolysis process. It is where the reaction takes place in. The most common reactors are fluidized bed reactor and fixed bed reactor. A new technology presented in the pyrolysis of biomass is radiofrequency, which is the one that we chose in our project. It's promising due its attractive advantages like rapid heating, easy adaptation to biomass flow, and high energy efficiency. There are various biomass sources available in the UAE in different amounts. As we all know, the UAE is one of the largest producers of dates, being the fourth in the world, with 750 tons of fruit produced per year. Moreover, plastic waste are available in million tons all over the world. All of these waste can be utilized to produce bio-oil. As in our case, we will use a blend of both date seeds and plastic waste as our feedstocks. Our problem statement is to produce bio-oil, which is biodegradable, safer, and has lower emissions to the environment. Secondly, designing a system that produces bio-oil from pyrolysis using radiofrequency technique. Solar energy will also be used to remove the moisture content from our feedstocks. Experimental and simulation approaches will be used to identify the optimum conditions for the higher yield of bio-oil. And lastly, bio-oil properties will be measured such as heating value, ash content, water content, solid content, density, and viscosity.
Our project objectives are:
to design a pyrolysis system for bio-oil production via radiofrequency technology using a blend of date seeds and plastic waste. To perform the experimental work for bio-oil production using radiofrequency approach. Also, to simulate the pyrolysis process using Aspen-HYSYS simulation. To design our flow sheet, we used Visio software. The flow sheet basically explains the whole pyrolysis process. The first step in the process is to reduce the size of the feedstock. So, for the date seeds, we will be using a grinder, and for the plastic waste, a crusher will be used. Then the second step is to remove the moisture content from the biomass by drying it. The plastic waste and date seeds will be used as a blend to produce bio-oil, so a mixer is needed. Moreover, the torrefication process, which is a thermal treatment used to enhance the biomass properties and produce a high-quality fuel, will be performed in a heat exchanger. Then the biomass will be introduced in the pyrolysis reactor, which contains an airlock to keep oxygen and the unwanted air out of the reactor. Our project reactor works with radiofrequency technique. After that, the products exit the reactor and enter the cyclone for char collection, since cyclone is a separation machine used to separate solid particles from gases that enters the condenser where the bio-oil condenses and deposits at the bottom, and the non-condensable gases are recycled to the combustor as burning fuel or collected for other purposes. For the process calculations, we generated the chemical formulas for date seeds and plastic waste using ultimate analysis taken from several researches to estimate the product's mass and energy content. Using Excel, we balanced the chemical equations. As seen in the first table, the heating values were assumed and the lowest heating value is for syngas, while solids have the highest heating value. Then, the previous heating values were used to find the mass and energy content of each feedstock, and then we combined them to find the total mass and energy content of the blend feedstock. The pie chart shows that the bio-oil energy content is 33% and the mass is 46% of the blend feedstock. This percentage is based on theoretical approaches. For the design of our experiments, we used Design Expert 12 software to help us configure the set of runs that we will perform in Serial Design Project 2. We used the response surface methodology from the software and chose 3 parameters that we will conduct our experiment according to the change of them with response to product yield. The 3 parameters are holding time, temperature, and particle size. The holding time range is from 450 to 550 seconds, temperature range from 350 to 600 degrees Celsius. We chose this range to study the effect of low temperature and radiofrequency. And lastly, the particle size range is from 125 to 740 micrometer.
Having a good quality feedstocks results in getting a good quality output. Both ultimate and proximate analysis are important. And according to the shown numbers, we are expecting high yield of bio-oil and syngas because they are directly proportional to the volatile matter. And in both of our feedstocks, the volatile matter has the maximum ratio. Moving to our main output. Bio-oil has 10 to 20 times higher energy density than the original biomass. So we are expecting to have a higher heating value, around 20 megajoule per liter. Also, some important properties are going to be measured, such as ash content, heating value, density, and viscosity, by using different equipment such as pinometer, dryer, tube furnace, muffle furnace, ultimate analyzer, and bomb calorimeter.
Coming to the cost estimation. For the cost estimation, our approximate total cost is 4,800 dirhams for the equipment we will be purchasing. This presentation addressed the theoretical background, the project design, and the process calculation. Thank you for listening toward a clean and sustainable future.